So far in electrochemistry, we've done two things. First, we've come to the appreciation that electrochemistry is nothing more than our ability to harness oxidation reduction reaction. So we spent a lot of time looking at what is an oxidation reduction reaction, being able to balance an oxidation reduction reaction, and have a sense of what the number of electrons is that are flowing as things become oxidized and reduced. Having done that, we appreciated the fact that while pretty much oxidation reduction reactions happen everywhere around us, it is our ability to, in fact, organize them in a certain way mechanically that allows us to get anything useful out of them. This idea of creating something called an electrochemical cell that we can work with. So we end up devising these different ways of making an electrochemical cell that might look something like this, so that having done so, when that electron flow occurs, there's an outcome of it, an output from it that's easily measurable as something that we can take advantage of. So you see a cell design right here, and we have this ability now to make the electrons flow in such a way that, what do you know, we can actually measure an electrochemical potential. Of course, as I create this cell, it's important that I be able to give everything a name. So I've named the fact that there is a place where reduction takes place, a place where the oxidation takes place. We've talked about the signs associated with this electrochemical cell. We have all of the nomenclature in place so that from here on out, for every electrochemical cell that we look at, we have a kind of convention that lets us talk about it in ways that everybody can understand. And now that we've done that, we can start to get a little bit more quantitative about what's taking place. And certainly, as we look at electrochemical cells and we start to get more quantitative, the most important thing that we can ask ourselves about is just exactly how much work we're going to be able to do with this electrochemical cell. Turns out that what will determine the amount of work that can be done by an electrochemical cell depends upon two things. It depends upon how many electrons get to flow through the electrochemical cell, and it depends upon how big the potential drop is, how big the voltage drop is associated with that flow. Well, that voltage drop, here seen as about ½ a volt, is directly related to the free energy of the system. It's directly related to the equilibrium constant for the system, as we will see. For right now, though, I want to talk about how it is that we are able to effortlessly put together tables that show for electrochemistry the same kinds of data that you can get out of thermodynamic data, the same kinds of data that you can get out of equilibrium constant data. I'm going to teach you how to build what we call tables of half-cell reactions that will allow us to be able to immediately put together any combination of chemical reactions, any combination of reductions and oxidations, so that the end result of it is a brand new electrochemical cell that might have the potential to do work for us.